All right, so in this lesson, we're going to talk through some concepts related to density. So we want to understand density and be able to calculate density using given values as well as real measurements of mass and volume for finding the density of objects. And we're going to do that in the lab later on. So what is density? Density is a physical property that you should know a little bit about just from experience in your everyday life. So it's a physical property that tells us about how close or the closeness of atoms and particles to each other in a substance. So really it's telling us about the spacing of particles. So a more dense object is going to have the particles more tightly packed together, and a less dense object is going to have less tightly packed. So here if I have, let's say, this little cube, if it's more dense, I might have the particles really close to each other in this cube. Whereas if it's less dense, there might be a little bit more spacing in between the particles that I see here. Okay, so more dense versus less dense here. So always be thinking about that spacing. To calculate density, because density is the amount of mass per volume, we're going to calculate it using a mass in grams divided by volume, and you can either have the unit for that volume in milliliters or in centimeters cubed. Those are two good units of measure that we can use here. I like to think about this as the love equation, so density equals love, because when I fill this in, density equals mass over volume. I feel like that looks like a little heart in my equation. So D equals M over V. Some people think DMV for this to help them remember that as well. So this is really telling me how much mass or how much matter is there in a specific volume of stuff. So that's really what this calculation is saying. You guys are going to have to be able to calculate density if I give you the mass or the volume. In the volume, you're going to have to calculate mass if I give you density and volume. You're going to have to be able to calculate volume if I give you density and mass. And examples of how to do those types of problems are shown down below on the site. So density really explains why things float and why I can really float and kind of or sink specific objects in liquids or even just different liquids in the same container themselves. So an object will float when its density is less than the liquid that you're attempting to float it in. So if I have a beaker of water, water has a density of 1.0 grams per milliliter. So now let's say I have an object, a sphere, and that sphere has a density of 1.5 grams per milliliter. Because it has a higher density than the water, the sphere will sink to the bottom of my container. It will sink in the water because it has a higher density than the water. That means its particles are closer together, they're more tightly packed, or I have more particles per volume. If I have an object, let's say another sphere here that has a density of, let's say, 0.75 grams per milliliter, this has a lower density than the water, so this sphere is going to float on top of the water. So its particles are more spaced apart, or there's fewer particles per volume. There's fewer particles in the same area, so it is going to float on the water instead. We see a great example of this when we look at water as a liquid versus water as a solid. So liquid water has a density of 1 gram per milliliter, whereas ice, solid water, has a density of 0.92 grams per milliliter. So we can see here icebergs in the ocean are going to float on top of the water because their density is lower, or the particles are more spread apart as solid than they are as a liquid. We're going to talk more about why exactly that is, because that's one of the really cool, unique properties that water has, that it's less dense as a solid than it is as a liquid. No other substance in the universe that we know of does that. All right, and then another example, floating in normal ocean water versus floating in the Dead Sea. So both of these are examples of salt water. When you add salt to water, it actually makes the water more dense. So it makes it easier for your body to float in it because your density is much lower in relationship to that of the water. So it's even easier to float in the ocean than it is to float in, let's say, Lake Michigan, which has fresh water. But the Dead Sea has super salty water. And because of that, it has a much higher density. So the lower density of your body tissues will actually allow you to very easily float in very salty water like the Dead Sea, which is pretty cool.